So picking up in 3.2, let's do a quick recap on what we did last week, since we all had a weekend. And I'm sure all thoughts are on functions when you guys weren't here. So in 3.2, we are looking at creating the formula using slope-intercept form. Okay, so we're using y equals mx plus b, and we talked about how the y is equivalent to what our function is. M is the average rate of change or the slope. X is your variable, and then b is your initial value. Okay, so in this one that we had done, we defined function and variable. We had two ordered pairs. We found the slope, and then from there, we used that slope and one of the ordered pairs to find the initial values to then ultimately get us to our equation. So we're going to be doing a lot of this as we complete this unit or this section. All right, so the temperature, T in degrees Fahrenheit, is a linear function. Right there, they've defined function for you of the number C, which is cricket chirps per minute. So right there, we have the ability to define function and variable. So I'm going to go ahead and do that. So my function, it appears as T, which is temperature degrees Fahrenheit. My variable is C, which is cricket chirps per minute. Okay, so based upon how we have defined function and variable, if I were to write that in an ordered pair, which goes first, T or C? C. All right, so I'm going to go ahead and do that because that'll be helpful as we read on. Okay, so 20 cricket chirps per minute corresponds to a temperature of 42 degrees Fahrenheit. Okay, this right here is giving us a relationship to my variable and my function that will create an ordered pair. So just be careful. 20 may go first, but it might not. Don't just assume. So 20 goes with cricket chirps. Cricket chirps is your variable. So sure enough, 20 will go first. And then 42 degrees Fahrenheit. So that does give us the ordered pair 2042. Okay. Then we are given that each additional chirp per minute corresponds to an increase of 0.25 degrees. I don't see two numbers, so they're not giving me an ordered pair, but what are they giving me? That's your slope. So they have given us the slope, and think about this. Our slope is the change in the function is degrees. So it is 0.25 degrees Fahrenheit per 1 chirp per minute. All right. Now, part A wants us to use a formula to express T as a linear function of C. So what they're asking us to do is to find that formula. Okay, so we know we're looking at y equals mx plus b. Y is my function, and my function is T. Slope they gave me of 0.25. I don't need to write it over 1 in the formula. X is my variable, and my variable is C plus B. Okay, to complete this formula that we need to write, we need the initial value. And this is where we use our ordered pair. Because in place of T, I'm going to put 42, 0.25, and in place of C, I'm going to put 20. So I get 42 equal, what's 0.25 times 20? The fingers going on your calculator, phones in your backpack, or out of sight, please. 5. Okay, so where we're at now, I'm just gonna rewrite that. We have 42 equals 5 plus B. Okay, so I want to solve for B. So I need to move my 5 and it's positive, so we're gonna subtract it. So I get 37 equals B. What have I just found? The y-intercept, also known as initial value. It is the y-intercept, you are correct. I'm just going back to the verbiage we use in functions. Okay, so ultimately now they want us to write the formula. And again, that is T equals MC plus B. So now when I create the formula, the only ones I'm replacing with a numerical value is the slope and the initial value. I leave the T as my function and the C as my variable. So it would be T equals 0.25 C, and my initial value is positive, so I'll put plus 37. That's ultimately what it's asking for. Slope was given, we had to find the initial value. All right, what temperature is indicated by 120 cricket chirps per minute? What were we given? Variable value. And the variable is C, so they gave me C equals 120. If I asked you to write that in functional notation, what would that look like? That's functional notation. Now, it wants to know the temperature, so what we're going to do is we're going to put 120 in this formula. So it would be 0.25 times 120 plus 37. So what is that? And this is what, 67 degrees Fahrenheit. Okay, couple things. If I asked you to explain the temperature at 120 chirps per minute is 67 degrees Fahrenheit. If I asked you for the ordered pair that corresponds with this, what would that ordered pair be? Okay. All right. Water freezes at 0 degrees Celsius, which is the same as 32 degrees Fahrenheit. Also, water boils at 100 degrees Celsius, which is the same as 212 degrees Fahrenheit. Okay, so when I look at this, I'm like, I'm gonna guess they're giving me some ordered pairs. Because they're talking about a relationship. Okay, but I don't know yet which one is my function and which one is my variable from what I've read. All right, so part A. Use the freezing and boiling points of water to find a formula. So ultimately, this is what it's asking me for. Expressing Celsius temperature C as a linear function. Okay, right there, I know what my function is. C, which is Celsius degrees. Of the Fahrenheit temperature, so F Fahrenheit degrees. So I know my ordered pair is variable first, then function. Okay, so now I can go back up here and write my ordered pairs. So I know that 0 degrees Celsius goes with 32 degrees Fahrenheit. So is my ordered pair 0, 32? Oh, this is where you have to be careful. 0 degrees Celsius, Celsius is my function. So 0 goes here. And that's probably one of the biggest errors students will make. And then the second one, 100 degrees Celsius. So that goes with Celsius. 212 degrees Fahrenheit. So that's important. Okay. All right. So in order to find the formula, we need two things. We need the slope and we need the initial value. So we're first going to find the slope. So this goes back to when you're given two ordered pairs. We're going to apply the formula that we looked at. I'm going to label this x1, y1, x2, y2, because the slope formula is the difference in y's. So it's y2 minus y1, 100 minus 0. The difference in x's, 212 minus 32. So calculate that. If it isn't terminating, give me normal rounding 2 decimal places.
Six.
5, 6. All right, so when I look at this, since it's positive, then I know it increases, right? If I was looking at it as an average rate of change, this would be, so this would be over 1. So there is an increase of 0.56 degrees Fahrenheit for every 1 degree Celsius. So just going back to things that we have done. All right, so now I need to find the initial value because here's my slope. Y equals mx plus b, but y is our c equals, whoops, mf plus b. All right, so we know m is 0.56. And then we're going to substitute in either one of these. We looked at last week that it doesn't matter which one you substitute in, you'll still get the correct initial value. I'm just going to use the first one. Okay, so this would be 0 equals 0.56 times 32 plus b. What's 0.56 times 32?
$17.92.
17.92?
Yep.
Oops, 92 plus b. So if I want b by itself, I'm going to subtract 17.92. So I get negative 17.92 equals b. This is your initial value. So now I have the pieces I need to find the formula, which again is C equals MF plus B. And the only two that we put numbers into is for the slope and the initial value. So C equals 0.56 F. Now, you can put plus negative 17.92, or you can put minus 17.92. All right. Part B. What is the slope of the function? Well, we already found that. Explain its meaning in practical terms. Okay, so I'm going to rewrite it as an average rate of change, which would be 0.56 over 1. And we know it's the change in the function. So the 0.56 would be degrees Fahrenheit over the change in the variable. So this would be degrees Celsius. All right, so when I explain it, then I start with my numerator. Y'all, did you not catch that? Somebody catch that, please. Before. This is the change in function. The function is C. I said that, but I wrote the wrong letters. Over the change in the variable, and the variable is Fahrenheit. Okay, so we're going to start up here. This is positive, so what do we know the Celsius temperature is doing? Correct. So the Celsius temperature increases. We're going to say how much it increases, 0.56 degrees per what? 1 degree Fahrenheit. Okay. All right. 4. Study of average driver speed on rural highways found a linear relationship between average speed S in miles per hour and the amount of curvature D in degrees of the road. On a straight road, D equals 0, which makes sense. Straight road, there's no curvature, right? So it's 0. The average speed was found to be 46.26 miles per hour. Okay, there's 2 numbers. So I'm going to guess that this is giving us an ordered pair. I just don't know which number. I don't know if 0 is the function or the variable yet. This was found to decrease, pay attention to this, decrease by 0.746 miles per hour for each additional degree of curvature. Okay. All right, well, let's talk about this right now. What does decrease mean? Negative. Okay, so what they're giving me is my slope, and it's negative 0.746 miles per hour for each additional 1 degree of curvature. That's how that reads. So when I read that and I look at the slope that is given, we know that the numerator is the change in the function. So if the numerator is the change in the function, is my function S or D? S. Your speed at miles per hour, which means our variable is D, which is degrees of curvature, or curvature degrees. So my ordered pair would be DS. So then I can come back up here and it said when D is 0, S is 46.26. Okay. So again, it wants us to find a formula. So y equals mx plus b. You don't have to write that every time. I just y is my function, which is s equals my slope they gave me, negative 0.746 times the variable, which is d plus b. All right, so I've got my slope, they gave it to me. The other thing that I need is my initial value. So this is where we substitute values in. So 0 goes in for D and 46.26 goes in for S. Oh, this ends up being really nice, doesn't it? It's 0 times anything. 0. So we get 46.26 equals B. This is your initial value. So now we have all the pieces to write the formula, which again is S equals MD plus B. But the only two we substitute numerical values in for are the slope and the initial value. So S equals negative 0.746 D, and this is positive, so plus 46.26. Okay. Express using functional notation the speed for a road with a curvature of 13 degrees. What was given?
The variable.
And my variable is D, so this would be D equals 13. So how would I write that in functional notation? S at 13. Now, part C says calculate round to 2 decimal places. So S at 13. So now we're going to substitute it into this formula that we created. So S at 13. So calculate that for me. Tell me what you get.
$36.56.
Thank you. And what are we talking about here?
Miles per hour.
If I asked you to write that as an ordered pair, what would it look like?
13. This 5 minus this. Sorry, not 36.
I got you. Okay. So on this next one, I want you to define the function and the variable. And then what that ordered pair is, and then see if any ordered pairs are given. All right, what did you define as the function? And what does that represent? Say that again. Okay, can we even be more specific? Yeah. Degrees Fahrenheit. Now, if you didn't include that up there, as long as any questions asked, you then label correctly, you would be fine, but I'm just gonna go ahead and take care of that. All right. So then that means A is your altitude, and did it give me more specifics on that? Okay. And notice it is 1,000 feet. Because if you calculate 2, it doesn't mean 2 feet, it means 2,000 feet. So be careful on that. All right, so we know then that that ordered pair is A T. Okay, so were you able to find any ordered pairs? What was one of them?
8 and 30.
8,000 feet, that's your altitude, temperature. Oh, here we go. I jumped over here. Is 30, so that is correct. All right, what's the other one?
18 minutes.
That's where you have to be careful. 18 goes first because it said temperature of -20, temperature is function, so be careful there. Okay, so it says calculate the slope, so this goes back to the formula. X1, Y1, X2, Y2. So my slope is the difference in your Y, so -20 minus 30. Your difference in variable, 18 minus 8.
-5.
-5?
Yep.
All right, so we have -5. Now, this is gonna ask me to explain it in practical terms. So I'm gonna look at it as an average rate of change. -5 is my numerator. And the numerator is always your change in what?
Function.
Function, change in function. So I come up here and that's degrees Fahrenheit. What does negative mean it's doing? Decreasing or dropping. Over 1, and the variable is, so that would be 1,000 feet. All right, so now I'm going to explain that. Okay, so I can say that the temperature is you can either put decreasing or dropping. Now, when I say the numerical amount, am I going to say it's decreasing -5? No, the word decreasing, decreasing takes the place of the word, of the negative. So it's decreasing 5 degrees Fahrenheit per 1,000 feet. Okay, all right. So now we're gonna write a formula. Well, we know we go back to y equals mx plus b. My function is temperature. My slope we just found to be -5. My x is my variable, which is a plus b. So now we need the initial value. So we always pull one of the ordered pairs. They both would done, if they're both done properly, you get the same answer. I'm just gonna go ahead and use the first one. Be careful. So T is the 30. -5 times 8 plus B. I get -40 plus B. Now, don't subtract 40 to move it to the other side. It's already negative. So we're gonna add 40. So we get 70 equals B. This is your initial value. So write a formula which is T equals MA plus B. So we're going to substitute the numbers back in for the slope and the initial value. So T equals negative 5A, and this is positive, so plus 70. How high is the aircraft if the temperature is 0 degrees Fahrenheit? What was I given? This is where you need to be careful. You're given the function value. So you will not do T at 0 degrees. That's not what it's asking. Okay. So when you look up here, where does, let's see, temperature is T is 0. So you have to put the 0 in place of the T. So it'll be 0 equals negative 5A plus 70. Now, what is your first thought on how to figure this out? Do what? Okay, so you're doing a linear equation, which is correct, which is what we'll do. Some people might look at this and go, oh, I need to do y1 equals and then y2 equals 0. But we don't need to do that on this one because we have a linear equation because this is raised to the first power. So she is correct that we're going to move the 70. So we're going to subtract 70 and get negative 70 equals negative 5A. Divide both sides by negative 5. So what is it? 14. Thank you. 14 equals A. Okay, so 14 what? 1,000 feet. What would that ordered pair be? 15-0. Okay. All right, so that finishes 3-2, which is due Wednesday. 3-3, we're going to get started on and just do a little bit of this. In 3-3, we will on Wednesday be utilizing some new things on the calculator that we haven't done before. Okay, and then a reminder, the unit quiz is after 3-3. So there's a good chance we'll finish 3-3 on Wednesday. But wouldn't do the quiz until next week. So, okay. So if I asked you to explain this function, what would you tell me? The function is increasing at a decreasing rate, okay? But now we're talking about linear. So what is this line doing, or this function? It is increasing at a constant rate. So that's the key with linear. It has a constant rate. Okay. So one of the things that you might be asked to do is you may be given information from a table. In a table, what's always on top? The variable. And we have the function. Now, one of the things that you've been asked to do is to calculate the average rate of change from a table, and then that would help you see what kind of rate. Does it have an increasing rate or a decreasing rate? Because you would look at the two numbers, okay? So one of the questions that you might be asked is the data in each table linear? So the key right here is to look to see if it's linear. Well, we know it's linear when it has a constant rate of change. So if you had to show this, or if I asked you to prove or figure out if it has a linear correlation or a constant rate of change. I'm not gonna require that you find the average rate of change 1, 2, 3, 4 times, okay? So I'll only require 2. So when you're asked, then pull the first 2. So we're gonna find the average rate of change from 0 to 2. So I do the difference in the function, so that would be 15 minus 10 over the difference in the variable, which would be 2 minus 0. That's 5 halves, which is what, 2.5 over 1? All right, so there's the average rate of change. Now, if this table has a linear correlation, any of the other ones will have what average rate of change? The same, 2.5. It would be constant. So then what I would want you to do is go and pull the last 2. So then we're going to look at the average rate of change from 6 to 8. So we would have 30 minus 25, 8 minus 6, and again, we would get 5 over 2 or 2.5 over 1. And because these are the same, then we know this table has what type of a relationship or what type of a function. It's linear, okay? So if I asked you to explain, now, I'm not asking you to explain what the function is. I'm just asking you to explain if the question, is it linear? So you would say, yes, it's linear. Whoops, not linear, linear. And how do I know this? Because the average rate of change is what? The same or constant. Now, I had someone ask in my 9:30 class, so like when you guys explain this, you would say the function is increasing at a decreasing rate. So here, I would word that as, I wouldn't say the function, I would say the what? Population, because function is population. So I would say the population is, now look at the table, what is the population doing? Increasing at a what? Constant rate. So it did not ask for that, but eventually we may have to do that, okay? All right, so we've got a little bit of time. Let's go ahead and do part B. So again, I'm going to do the average rate of change between the first 2. And this is 0 to 2. 6 minus 3. 2 minus 0. So 3 halves or 1.5 over 1. And then I'm going to do the last 2. From 6 to 8. So 48 minus 24 over 8 minus 6. That 12 over 1?
Yep.
Is the data linear? How do I know that?
Thanks for the same.
Because the average rate of change is not constant. Now, if we said the population is, what is it doing? Increasing at an increasing rate. Yeah, didn't ask for that, but if we did, okay. All right, so I was a little bit quicker than I was in my 9:30, got a little bit more done. I don't want to get too far ahead stuff before we're gonna go today, okay? So, couple of things, though, I still got to do though.